In this lesson, we are going to cover the first part of chords and arcs. So a little bit of review. Points, lines, and planes are three undefined terms in Euclidean geometry. A point is just a location in space. It has no dimension. We represent a point with a dot. Okay, so while the dot does have dimension, the point itself, the location, does not. Okay. We have two types of lines. A line is just made up of infinite number of points that are arranged in a straight path, and it has infinite length, but no width or depth, although our representation of the line does. Okay, so a line, right, see how it has the arrows? It goes on forever. There's also a line segment, which is just part of a line. It includes any 2 points, the locations, and then the line, and all the points, the locations that are in between those 2 points. Then we have a plane. A plane is made up of an infinite number of points extending in every direction in 2 dimensions. So the plane has no depth as well. A review of parts of the circle. The first thing that we have is the center of the circle. When we name a circle, we name it according to the center. So usually the center will have a letter like a P or a Q, and so we would call it circle P or circle Q. So we have the center. And that's the dot that is at equal distance from the endpoints of the circle. Then we have the diameter. Okay, the diameter is the line that has its endpoints on the edges of the circle, and it goes through the center of the circle. The radius is a line that has one endpoint on the edge of the circle, and then the other endpoint is on the center of the circle. So the radius is half the length of the diameter. A chord is just a line that has its endpoints on the edges of a circle. Okay, it doesn't necessarily have to go through the center. So we could call a diameter a chord as well, but we can't always call a chord a diameter. Okay. An arc is a part of the circle that's formed by 2 points that are on the circle and all of the points of the circle that lie between those points. We have 3 sizes of circles. We have the semicircle, the minor arc, and the major arc. A semicircle is an arc whose endpoints are also the endpoints of the diameter. So for example here on this one, if this line AD, is a diameter, okay, then we would name the semicircle by the 2 endpoints and then just any 1 point on the circle in between. Okay, so here our endpoints are A and D. Okay, so our semicircle that we would call it would be, we could call it ABD or ACD, or we could call it DCA or DBA. It's just important that we have the A and the D on either side of our, at the front or the back. So here we have the A and the D, D and the A and the D. And it doesn't matter, just as long as one of the points is there in the middle. That's how you name a semicircle. A major arc is an arc that's larger than a semicircle. It's named by its 2 endpoints and 1 endpoint in between. So for example, here, the yellow line is a major arc, right? It's bigger than a semicircle. So we want to make sure and have E and D on the edges, and then we can pick any of these points in between. So here we can say EBD right there, or you can also call it ECD, or we could call it DAE, or DCE, or DBE. So just as long as the D and the E are on both ends, and then you pick 1 point in between. A minor arc is an arc that's smaller than a semicircle. It's just named by its 2 endpoints. Okay, so for example here, for this minor arc, we would just say BD. We don't need to call it BCD, because a minor arc could also be BC or CD. So it's just the arc of the circle that is smaller than a semicircle. Okay, a central angle. All right, you can place chords. All right, so chord would be like BD, or the diameter, right? Diameter is also a chord, AD, or let's see if we have any other ones. No. Okay, so you can place any chords on there and the radii on a circle so that they create angles. All right, if the angle has its vertex, remember the vertex is where the 2 points come together. okay? If the angle of the vertex is at the center of the circle, then it's called a central angle. Okay, so that means that the angle has to be, the vertex where the two lines meet has to be in here where circle F is, all right? So any of these angles right here are going to be our central angles. And so we could call these, we would say angle AFE, or we could say angle EFD, or we could say angle DFB, or we could say angle BFA. Okay, those are all central angles. Okay. An inscribed angle is if the vertex of the angle is on the circle itself. All right, so remember the vertex is where it comes together, right? The two lines come together. So an inscribed angle, if we look up here, see here's where we have a angle and the angle is on the line, right? Or it's on the circle, okay? Here would be another vertex, okay? Or sorry, another inscribed angle where the vertex is on the edge of the circle. So here we could label that as angle FBD, or we could say angle FDB. Okay, so those are two inscribed angles. So here we want to give the name of each part of circle P. All right, so here we have AD. If it's circle P, that means that this dot is the center. All right, so since this line AD is on the edges of the circle and it's going through point P, then we call this a diameter. Okay, PB, all right, B is on the edge of the circle and it's going to the center point there. So P is a radius. Okay, BD just has its endpoints on the edges of the circle. It's not going through any center type. Okay, so we just call that a chord. All right, angle BPD, BPD. All right, see the points here are on the edge of the circle and the vertex is the central angle. Okay, so this is a central angle. All right, BDA, BDA. See how D here, these two lines are converging. The vertex is on the edge of the circle, so this is an inscribed angle. Okay, and then point P, since this is called circle P, we know that point P is just the center of the circle. Okay, so here it says circle P has diameter AD. We want to name two minor arcs and their associated central angles. Okay, so remember, minor arcs are less than a semicircle. Okay, so the semicircle is made up of the endpoints of the diameter, which is AD. So we're looking for something that's smaller than AD. Okay, so and we're looking for ones that have associated central angles. All right, so here we could say that AC is a minor arc, but since we don't have any lines connecting, we don't have a central angle. So let's look up here. Okay, AB, right? That could be one of our central angles or one of our minor arcs. Okay, and for AB, the associated central angle would be APB. Okay, another minor arc would be BD, and its associated central angle would be BPD. Okay, two major arcs, remember the major arcs are bigger than the semicircle. Okay, so here, if we go from A to C this way, right, we could say A and C as the endpoint. So we have to pick a point in between. So we can just say B, okay? So let's say ABC. That's one of our major arcs, okay? Or let's say if we went from A to B going the other way, though. So, let me get my pen color here. So if we went this way, okay, and so that's why we want to say put a C there in the middle, ACB. So do you see why it's important with major arcs, why we include a point? Because if I just put AB, right, then I don't know which way, I'm going from A to B, right? That's my direction. We have to put the C in there in the middle to tell us that we're going this way. to B, right? A, C, then B. All right. Okay, and then name two semicircles. Okay, the semicircles have to have A and D because they're the diameter. Okay, so here we have to have A and D on the edges, and then we have to put a point in between. So we'll say A, B, D. Okay, and then to go the other way, we can say A, C, D. Okay, and again, that's why it's important that we put the point in between because the semicircle can go either way, right? If you just put AD, we don't know if we're talking about the top of the circle or the bottom of the circle. Okay, so here we want to just fill this in, okay? This says that circle D consists of all points that are what? Blank point D, okay? Then this says equidistant, okay? Equidistant from. Okay, so circle D consists of all the points that are equidistant from point D. All right, so the circle is only made up of the line of the points that are actually on the edge of the circle. All right, so like H does not make up the circle. The only points that make up the circle are G, F, C, and E. Okay. Name three chords. Okay, so remember, chords are just lines that have their points on the edge of the circle. So here we could say GF, right? GF right there, that would be a chord. We could say EF, all right? Because even though we know EF is a diameter because it goes through the middle right there, we could still call it a chord. And then we could say EC, that's a chord as well, okay? We want to list all the radii shown for circle D. So that would be any lines that are going from the edge of the circle to the center. Okay, so here if we look at D, we just want to look at all the lines that go from D. So we can say DG, we could say DF, we can say DC, and we can say DE. Okay. Here it says explain why the center of the circle is not part of the circle. Okay. So remember the definition of a circle is that it consists of a set of points that are equal distance from the point identified as the center of the circle. Okay. So the point that is the center of the circle is not the same distance from the center as G, F, C, and E, right? Because we're talking about the distance from D. So that's why D is not part of the circle, okay? It's the point where we're starting from. Here it says, what are two common characteristics of EC? So here's our EC, EF, and GF. Okay, there's several things that are in common, right? They're all line segments. One of the main things that pops out to me is the fact that they're all chords, right? They all have their endpoints on the edge of the circle. So I know that they are all points. We could also say that they are all on the interior of the circle. That's something else that they all have in common. So several things they have in common there. F says a central angle of a circle is an angle whose vertex is blank the circle. All right. So remember, a central angle means that it's in the center of the circle. Okay. So in center of the circle. Okay. And its sides are blank of the circle. All right. That means its sides are radii. Okay. Right, because they go from the middle to the edge. Okay, given that angle GDF is a central angle, what is its associated minor arc? All right, so here we have GDF. That means that the associated minor arc is GF. Because remember, minor arcs we only have to have 2 points on there. And that is the end of Chords and Arcs Part 1.